Welcome to the hyperbolic coding chamber on this momentous and great meat consumption day, also known as Turkey Day, Turkey's Giving, Codes Giving. Actually, today is Codes Giving Day. So, what are we thankful for in the hyperbolic coding chamber? We're thankful for the underlying DAG structure and dynamic programming problems. We're thankful for stacks, queues, and we can't forget index. We're grateful for Dijkstra's algorithm. We're grateful for the two-pointer method, our forefathers and their great four daughters, Siena, the algorithm design manual. We're also grateful for elements of programming. We're also grateful for Gail Lack McDowell, author of the Cracking the Coding interview. We're grateful for system design interviews. We're grateful for technical interviews as well. So if you haven't done any technical interviews, you're missing out on something to be grateful for. And dare I say it, need I say it, and shall we, I don't know if we should dare to say it, but we might have to be grateful to the LeetCode devs. So, you know what? Even after all of the assault, the physical, the mental assault on our minds from these problems, the LeetCode devs, they mean well. And so as a result of the hard work they've done in creating this content and these puzzles for us to solve, we've been blessed with a mental decision tree that hopefully will withstand the test of time. But we shall see about that. But yeah, dare we say it, we might have to be grateful for LeetCode.com. Feels strong, man. Under the umbrella of science and code executing characters on a screen, pixels on a screen, characters arranged in a particular way, creating instruction sets for silicon, we might have to be grateful for that. So, feel strong, man. So, yeah, we have a great Turkey Day upon us, but can we truly ingest the turkey without having slain the beast? I feel like someone had something. I think I was reading a Hacker News comment or something like that. Or something someone said. Something about, I can't remember, but I think it was a Hacker News comment that someone said something about back in the day when we were just apes. There was something to slaying the beast or working with your village or something. Pretty much having to stake your point. Pretty much stake your work ethic or work output or something before having consumed for the day. So insert something about having to have done or having to have put a bit of work forth before sitting back. Something about earning your leisure. Something deep about that. But I don't think we have to do anything specifically on Thanksgiving Day. Most people, I think that's particularly why we have a holiday. Most people have already staked their work, before the day, probably for years up to that point, maybe up to a week before that point, even yesterday. So there's no real point in doing anything particularly on today, but this is the daily challenge, so it is a necessary evil. So it must be done. But yeah, something about earning leisure, something. But that being the case, we do have comments as per usual that we must respond to. And we have a legendary comment from Jibin Thomas. It says, "You need to stop biting your nails, dude." True. Actually true. Today, I am thankful for you. Actually true. So, yeah, I definitely have tried to quit biting my nails, but something is very difficult about that. For some reason, to me, it's like a thinking mechanism for something. I think it probably has to do with an inability to still a wandering mind. But usually when I'm thinking, I need something to anchor my mind to. So, for example, I think a lot of people experience this, but in the shower is a great spot where people spend a lot of time thinking deeply. I think research has shown that people who walk, like if you literally walk while thinking of something critical, like something that you're mulling over, like a work problem or a personal problem, you tend to have better solutions. So I think it's probably a universal effort or used to having something to anchor your mind to while you think. But yeah, biting my nails seems to be one of the stationary methods of achieving that. So maybe we need a new method. When my hair was longer, I would twist it instead, so that helped. But yeah, we definitely need one that is less destructive. So yeah, I will look into more methods. I tried to use some nail sauce. It's like some specific thing you can buy on Amazon. You put it on your fingertips, and whenever you put your hand into your mouth, you get a bitter taste. But it seems I'm impervious to the effects of negative reinforcement. This might be why we are continuing to do LeetCode. So that being the case, we'll be looking into these methods. I always appreciate the comments. There was another comment the other day about moving the camera up to the top right corner, and that was actually a pretty good comment. So yeah, that the videos are definitely better because of that. So that being the case, we're being tormented by some problems. I do think we've been on the easy path, but at this point we're just playing for the completion awards. Because on the LeetCode website, I really just want to have finished all the problems. I remember when I tried this challenge, not a challenge, but I was trying to do this more frequently. There were like 1,700 problems. So in 2 years, they've added like 600 problems, which isn't the worst thing in the world. I think I calculated that they add about one problem a day. So as long as we solve one problem a day, and they're not always easy problems, as long as we solve one problem a day, we should be able to finish all of those. But I know that definitely the best way to learn, I wouldn't say learn the fastest. I think a lot, I don't know. I think I learned a lot doing mediums, but the information wasn't retained. So maybe if I did mediums for longer term, the information would be retained, but it's hard to know. That being the case, there are other things you must do, so easies are a good balance. So hopefully we can finish all the problems soon. But it definitely seems like there's still value to be extracted from these easy problems, and there's been a lot of small concepts we've been learning. So that being the case, I'm just going to jump into it and keep it 1,000. And we're going to do a nice, thick 45-minute session. Nice round number. And yeah, hopefully we can solve a lot of problems. I've been stuck on a nutty problem, so hopefully we can solve that. And yeah, we're just going to jump into it. So this is going to be day 163, I believe. And it is unknown. Oh, no, it's day 162. So we're just going to run with that, and we're going to see how far we get. So we're doing a repeated substring matching problem, and we just have a bit of an if statement that is creating quite an issue for us. This is going to be ghetto. I'm pretty sure it still works, or it breaks where we're at. If I click run, so we returned a false for this case. So basically the problem is we have a problem called repeated substring pattern, and we're given a substring, which is this substring here, S. We have to be able to tell whether or not whether or not the string is just a repeated substring. So the answer is false here, because actually we have Bob, Bab, 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 and Bab. So the answer should be true. It's just Bab repeated 5 or 6 times. So they expected true, we returned false. So I wonder why we returned false. 1, 2, 3. All right, so this should work. But nonetheless, the end up returning false. And s dot length mod len equals 0. Mod len right, so let's add this test case. And even then, six, 7, 8, 9, 10, 11, 12, 13, 14. Oh, it's 15. We assumed earlier that if it was odd, I guess we can still remove this code up here. The odd code at least. I think this should still work. So we output false. Right, and since we're going back, we removed our odd code. We have to start our length at 1. Yeah, this was a miserable problem. Also, I forgot to start the timer, but I'm pretty sure we're probably at like 42 minutes or something. This was a miserable problem, and I'm not exactly certain why. Oh, I guess it's not that bad. The console log was making it pretty erratic. It looks like the worst case, this is n squared. In the worst case, the average time is probably less than that, but the worst case is that we're checking length 1, starting from index 0, and then we pretty much check going through like this with both P1 and P2. So I would say this is n squared with constant space. I'm really curious to see if there's a linear time solution. Maybe there are no solutions to this problem. Or LeetCode is down, maybe? You could probably remove this first case now that I'm looking at it. I'm curious to see if LeetCode is just down. I mean, if the solutions portion is just down, or if there's just no solutions posted. So it looks like solutions is not functioning. RIP. It's kind of sad to think about because I'm sure someone has to respond. Oh my god, that is actually a genius solution. example, ABC, ABC. Your string S contains a repeating substring. This means you can shift and wrap around your string some number of times and have it match the original string. We have A, B, C, A, B, C, shift 1, C, A, B, C, A, B. Yeah, this is what I was thinking. It's exactly like checking a linked list cycle. Number 2 is Rab and Carp. It looks like there's definitely a solution for it, but it's not loading, which is kind of unfortunate because I really wanted to gobble up this intuitions. That's a little disappointing. Looks like solutions aren't working. Solutions is working for this problem. I wonder. Oh wait, now it's working. If your string S contains a repeating substring, this means you could shift and wrap around your string. Raven Carp, I don't even know what that is. KMP, what kinds of math you have done? String prefix problems like stir intuition. For a string, to build a substring, if repeated over n times, and the substring must be a prefix of the string. If prefix is repeated multiple times in the input string, and the last value in lookup table must have a big number. We don't need to check for all prefix. We only need prefixes with lengths to half of input string. True. To add my experience here, I was doing LC repeating substring pattern today. What I understood is if I could reach up to the point for a string to be valid in this problem, interesting. This problem is really interesting. That's why I feel like easies are so flames. There's so much like little bits. It's like a small piece of thing, like a small piece that you ingest. Wow, that was a really good problem. Unfortunately, there's no like actually accepted LeetCode build solution, but this is a really good problem. Definitely return to. First, we build the KMP table, roughly speaking, DP. First row is the index. Second row is the character corresponding to each index. Third row is the value that the KMP prefix array would have at that position. Interesting. Interesting. I might have to look into KMP. You definitely have to look into KMP. Either way, we have the next problem. The Hamming distance. The Hamming distance between two integers is the number of positions at which the corresponding bits are different. Within two integers x and y, return the Hamming distance between them. So it's just the number of positions at which the corresponding bits are different. X and y, so we have one, different bit, same, different. And so the answer is 2. I think we want X or here. So we want one of them to be true. If one of them is true, then the other can't be true. So could we just do... Yeah, I think we want X or here. Because if they're different, one of them has to be a 1. It just has to, because it's only 1 and 0. So you could say dist is equal to 0. Return dist. We'll say for let I is equal to 0. I is less than 32, I plus plus. And we'll say const x bit is equal to x and 1, y bit is equal to y and 1, and we'll say x bit or y bit. Do dist plus equals 1, and then we'll bit shift x to the right once, and we'll do the same for y. Now let's check if this makes sense. Given 1 and 4, we'll mask x, right, which is 1. 1 and 1 is 1. We'll mask 4's first 1 bit. It's going to be 1 masked by 0. 4's least significant bit masked with 1 will give us 0, and we'll do XOR here. And we should do dist plus equals 1. Then we'll shift down 1. We'll have 0 and 0, but they're both the same, so we'd return false. I mean, it would be, the case would be false, so we wouldn't add anything. We have 0 and 1. Add 1. And I think this should work. God, there's no negative numbers allowed. I think this would be constant time, because if we have 32-bit integers, then we're just going to do 32 operations every time with constant space. So that was a nice little problem. No way, rotate string. Oh, these are me. That was a wait. My things are messed up. Island perimeter. I have number complement and license key formatting. So we'll do island perimeter first. You're given a row by column grid representing a map where grid sub I sub j, so we're given a multi-dimensional array called grid representing a map where grid sub I sub j equals 1 represents land, and grid I sub j sub 0 represents water. Okay. Grid cells are connected horizontally, vertically, not diagonally. The grid is completely surrounded by water. Okay, so anything outside of the multidimensional array is considered water. And there's exactly one island. There's exactly one island, one or more connected land cells. Island doesn't have lakes, meaning the water inside isn't connected to the water around the island. Doesn't have lakes, meaning the water inside isn't connected to the water around the island. Island doesn't have lakes. Water inside isn't connected. The island doesn't have lakes. Meaning the water inside what? Inside isn't connected to the water around the island. Island doesn't have lakes, meaning the water inside the multi-dimensional, inside the map isn't connected to the water around the island. One cell is a square with side length 1. The grid is rectangular. Width and height don't exceed 100. Determine the perimeter of the island. To the perimeter, okay. The grid is completely surrounded by water. Is there only one island? The grid is there's exactly one island. I think you could do this in linear time, or I guess m by n time. If we just iterate through, what if we just iterated through and the max value an island can give is 3. And it's 3 because there's only one island, which means one side has to be connected to another side. So if we iterate through, right, we know that if we find a grid, the max score you can get is 3, so we can just check around us, right? So we go here, right? We could check all 4 spots around us. We'd have one grid here, right? So we'd subtract 1 from 4. And then we go 2, 3, then we go to the next row, right? We check all around us, we'd have a grid, right? So we would just add 3. So we'd subtract 1 from 4. Then we check here, we check all around us, we have a grid all around us, so we would actually return 0. So we have 6 right now. Then we'd have 3, nothing. And then we'd have 2 here. So 3, 6, 9, we have 11. Then we have 14. Then we have 2. So I think since there's only one island, this is pretty straightforward. But let's see. Or I guess they want us to have the perimeter. So we can just do 4, let row equals 0. Row is less than grid.length, right? Do row plus plus, then we can duplicate the line above and we can say call, right? Except what we're going to iterate over is the length of the row. Now I have access to the specific row. And then there's going to be some spaces we want to check around us, right? We'll call these spaces, or we'll just call this offsets. This is going to be an array of tuples. So we want to check, the tuples are going to be X and Y offsets, and it's going to be hard coded because we want to go one above us. To go one above us, right, what we would actually do is subtract one from the row, right, and we would do nothing to the column. Now to check to the right of us, for example, if we have if we're in this black cube here, this one is surrounded by the black bars. To check to the right of us, right, row is actually going to stay the same, so we'll put 0 in here, and we're actually going to add 1 to our column. And then to check below us, right, we're actually going to add 1 to our row and do nothing to our column. And to check to the left of us, we're going to do nothing to our row and subtract 1 from our column. And then in here, we can just say the max value you can actually have is 3, but we're just going to set it to 4 to start. And we're just going to say if grid sub row sub call, right, equals 1, because that's when you can actually even check, right, because then you have an actual piece of land. And then we're just going to say for const x offset y offset of offsets, I'm going to say if grid, right, and we can actually use a safe navigation here in JavaScript, but we can just do grid safe navigation row plus x offset safe navigate y offset, call plus y offset equals 1. Then we're actually going to do max minus equal 1, and then we're going to do perimeter plus equal max. And max is kind of confusing. It might just be able to name it something simpler, like sides. So if we were just run this right here, right, we'd go to row sub 0, column 1, right? It does equal 1, right? Because we have 1 here, right? Then we're going to set sides equal to 4. We're going to do our offsets. We're going to say row plus -1 check behind us. To actually check above us, right? Safe navigation call plus y offset, which is actually 0, but you actually get null or undefined, and undefined is not equal 1. Then we can check if we stay in the same spot but move one column to the right, does it equal 1? No. Then we can check below us, right? Does it equal 1? Yes. We do sides minus equal 1, and then we can check behind us, and then we'll just add 3. So I think this should work. Seems kind of slow though, but I guess this is just linear time. We're just looking through the whole grid once. And I guess it's technically n by m times 4, but we could just drop the constant since this for loop only runs for the number of offsets we have, which is always constant. So you can take that away from the total time complexity. I think, yeah, I was going to say you can definitely do BFS or DFS here, but then you'd end up wasting space on the stack. This is basically constant space. Constant space. This is like an evolution of that other problem, the one that you actually have to use BFS for when there's multiple islands. Grid sub R sub C minus 1. Looks like they're only checking below them and behind them. But I don't... Ah, I see. That's really clever. That is really clever. Interesting. Why is it we only need to check left and up, though? So left and up, left and up, left and up. So you're traversing the grid from left to right, from top to bottom. For each land cell we are currently at, we only need to check whether left and up cells are land cells. Treat all the land cells as having a perimeter of 4 and add that up to the accumulated result. If that land cell has a neighboring cell, remove 2. Ah, 1 from each. I see. That's true. If you're touching between these two cells, if you can't. That's really clever. That is really clever. So here we have the complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to zeros. I think there's a flip bit. We really learned recently there was a flip bit thing you can do. Is it XOR for to zeros and its binary representation? For example, integer 5 is 1 0 1 in binary, and its complement is 0 1 0, which is the integer 2. Given an integer, return its complement. I think there was a thing you could do. We could do this manually, but I think there was a trick you could do. I think it's XOR. So you have 1 0 1, but if you XOR it with 1, they're the same, so you would get 0. Now if you XOR 0 with 1, you get 1. If you XOR 1 with 1, you get 0. So I wonder if you can just do return num XOR 1. Or maybe you have to do num XOR itself. No, that doesn't make any sense. Maybe it's a simple... There was a thing we did to flip all the bits, though. I don't remember what it was. But I think we can just do, we're going to iterate over it 32 times, and we'll return the complement. And then from here, I think all we should have to do is say comp plus equal num XOR 1. Then we can shift the complement 1 bit to the left, and we can shift num 1 bit to the right. Maybe what we want is num and 1. If we mask num for that one value at the end, I feel like this should work. We have 5, 2, and 1 because our input number is 5, which is 1, 0, 1. So it should say 5, then 2, then 1, which it is. Now if we console.log comp, so we push on the XOR of 1, which is 0, so we have 0. Then we have 2. Oh, we keep going. Right, we keep going for 32 bits. We end up flipping all the bits up to 32. I see. It looks like we actually have an endpoint. We'll call this MSB. Well, MSB equals 32 to start, and we'll iterate over it in advance. We'll actually have a temp, and we'll say we'll say if we'll say if temp masked by 1, we'll say MSB equals I. Right, and then we'll keep doing temp. We'll shift temp down by 1. So we will have is something like this. If we have 5, right, which equals 101, its MSB is the bit in the third position. So what we'll do is we'll mask the least significant bit with 1. We'll get 1, right? And then we'll mask it with 0. We'll push it down. We'll get 0, right? And then we'll get 1 again, which means our MSB is actually that bit. And we'll make sure to add 1. Otherwise, we'll end up with 0, 1, 2. 2 is our MSB when actually it's in the third spot. Wait, we should be able to get this. Output is 4. So maybe we're going too far. Maybe we just need to do I. Wait, I think this method is at odds, which doesn't quite make much sense. This is strange. I'm flipping the bits. I don't think we have to shift comp down at all, actually. I think what we actually should do is we'll say if num and 1, right? If the flipped bit XORed gives us a value which we can actually save into the number, then we'll actually save it. And the value we save into the number, we'll save it using OR. Using 2 to the I. Nice. So that should be constant time, and I think that is where we'll stop for today.